So what we were talking, f is continuous in either in f comma half or alpha comma half or half comma alpha. So here we can apply Bolzano's intermediate value theorem. What does it state? Whenever f is continuous in that interval, then what we can claim about Bolzano's intermediate value theorem? If f alpha and f half are not same, which is obviously not, then yes, yes. It attains every values between f alpha and f half. So right now, what is the value of f alpha? It is beta, and the value of f of half, which is k. Right? Obviously, beta and k are not same. We have already taken this. That means f will attain every values between beta and k. Now both are two rational numbers, right? Now by density property, we can say between two rational numbers, there are infinitely many rationals as well as irrationals. So according to this theorem, f will choose or f will take all that irrational values also, but which is a contradiction to our given fact that f takes only rational values, right? So we are writing by density theorem, there exists infinitely many irrationals between beta and k. And f will assume that irrational value, which is a contradiction. So our assumption was wrong. That means f is a constant function throughout the interval close 0, 1. F is constant throughout close 0, 1. Okay. Moving to the next example, write down example 4. If fx equals limit tending to infinity, then in the numerator it is log 2 plus x minus x to the power 2n sin x, and in the denominator 1 plus x to the power 2n. If fx equals this, limit tending to infinity of this ratio, explain why this function does not vanish anywhere in close 0 comma pi by 2, close 0 comma pi by 2, although f0 into f of pi by 2 is less than 0, although f0 into f of pi by 2 is less than 0. If fx equals limit n tending to infinity of this ratio, explain why this function does not vanish anywhere in close 0 comma pi by 2, although f0 into f of pi by 2 is less than 0. Now check, generally we know by Bolzano's location of roots theorem, when this condition satisfied, that means that at the end points the function is taking different signs, then there exists some point where the function vanishes. That means there exists some point c such that f of c equals to 0. Now we have to prove why this is not happening for this function. That means some condition must not be satisfied, right? So can anyone tell me what could be that condition? Yes, f is not continuous somewhere throughout this interval, right? Because that condition must have been violated such that this is not happening. That is, f is not taking the value 0 over this interval. Because we have, for Bolzano's location of roots theorem, we have total two conditions. Number one, f must be continuous throughout the interval, and number two, at the end point it will take the different sign. Here the number two condition is satisfied, still the theorem is not holding. Why? Because the first condition must have been not satisfied. So we have to find out that. That is where the function is not continuous. That is what is the point of discontinuity for that function. This is our main work. Okay. Now the interval given here is 0 comma pi by 2, right? That means 1 is already belongs to that interval. So whenever 0 less than x less than 1, tell me what will be the value of x to the power 2n as n tending to infinity. As n tending to infinity and 0 less than x less than 1, then what will be the value of x to the power 2n? No. In one of the previous classes, I explained this. Anyone else? 0. Yes, the answer is 0 because this is 0, this is 1, okay? X lies between this one. That is half, 1/3, 2 by third, 4 by 5, like this value. Then you are considering its power n, and then this power n is tending to infinity. That means half into half into half into half up to infinity times, or 2/3 into 2/3 into 2/3 up to infinity times. Like this, whenever it is very small quantity and it is between 0 to 1, that is, it is always approaching to 0. That is, x to the power 20 is tending to 0. Next, if x equals 1, then where it will go? One. And when x greater than 1? infinity. Right? Now we got these values. Put these three values in fx and find the values of fx when x lies between this range or this range or this range. Okay? Tell me one by one what will be the values. First case will be when mod x less than 1. Then when x equals 1 and when x greater than 1. First do this one. The first case. Tell me the value of fx. Just put the value of x to the power 2n for that range and you will get the value of fx.